Myself, Akshra, in the stream of ECE, bearing roll number I2. Today, my topic is probability density function. Now, we will discuss about probability density function. What is probability density function? A probability density function is a mathematical function that describes the relative likelihood of a continuous random variable taking on a particular value within a given range. This probability density function is also known as small PDF. Why do we use PDF? Discrete variables use PMF. Continuous variables require density functions. Examples: height of a person, weight of a person, time, etc. Mathematical expression for probability density function. In general, f of x greater than or equal to 0. Total probability equal to integral f of x dx equals to 1. P of a less than or equal to x less than or equal to b equals to integral a to b f of x dx. Relation to PDF. The PDF is the derivative of the probability distribution function, which we denote as fx of x. Small fx of x equal to d by dx capital Fx of x. That means if you know the PDF capital Fx of x, you can find the small PDF small fx of x by differentiating it. A PDF indicates the relative likelihood of a random variable being near a certain value. If the PDF is higher at point A than point B, it means values near point A are more likely to occur than values near point B. Probability of an interval. The core use of a PDF is to find the probability of a variable falling into a specific range. This is done by integrating the PDF over that range, which gives the area under the curve between the endpoints of the interval, not a direct probability. For a continuous variable, the probability of it taking any single precise value is zero, as there are infinitely many possible values. The PDF is not a probability itself, but a function whose integral gives probability. Non-negativity. The PDF must be non-negative everywhere, meaning f of x greater than or equal to 0 for all possible values of x. Total integral is 1. The integral of the PDF over the entire range of possible values for the random variable must equal 1, signifying that the probability of the variable taking some value is 100%. Derivative of CDF. The PDF is the derivative of the cumulative distribution function, and conversely, the CDF can be found by integrating the PDF. How to use a PDF one? Identify the interval, determine the specific range of values, example a comma b, for which you want to find the probability. Integrate the PDF. Calculate the defined integral of the PDF from the lower bound a to the upper bound b. Obtain the probability. The result of the integration is the probability that the random variable falls within that interval. Example, application financial analysis use PDFs to understand investment risk. By applying a PDF to investment returns, they can visualize the distribution of potential returns and assess the likelihood of returns falling within a certain profitable range or the probability of significant loss. Now we will discuss about properties of probability density function. First property is non-negativity. F of x greater than or equal to 0 for all x. Second property, normalization. Integral f of x dx equals to 1. Third property, probability in interval. P of a less than or equal to x less than or equal to b, that equals to integral f of x dx from a to b. Examples for probability density function are uniform distribution, normal or Gaussian distribution. For uniform distribution, f of x equals to 1 by b minus a. for a less than or equal to x less than or equals to b. Next, second example is normal distribution or Gaussian distribution. F of x equals to 1 by root of 2 pi sigma square into exponential of minus of x minus mu square by 2 sigma square, where sigma square equal to variance. Applications of probability density functions or statistics and data science. Second one, machine learning or probabilistic models. Next thing, signal processing. Next, reliability engineering. Last one, finance and risk analysis. Here some of the key points to know about probability density function. There are four key points. First thing is probability density function describes distribution of continuous variables. Next thing, always non-negative and integrates to 1. Third one, related to CDF common distribution function by differentiation. Examples, uniform, normal, exponential. There are two types of probability density functions. First one is discrete random variable. Second one is continuous random variable. Now we discuss about discrete random variable. Definition of probability density function for discrete random variable. The probability density function small PDF for a discrete random variable x is given by small f of x equals to sigma I equals to 1 to n p of xi into del of x minus xi. Here xi are the possible discrete values of the random variable x. P of xi is the probability of x that equals to small xi. Del of x minus xi is the unit impulse function centered at xi. Second one is continuous random variable. The definition of continuous random variable is a continuous random variable is one that can take any value within a given range. For such variables, the distribution function fx of x is continuous. Probability density function small PDF. The probability density function denoted as small fx of x is the derivative of the cumulative distribution function CDF capital Fx of x. The formula for continuous random variable is small fx of x equals to dfx of x by dx, nothing but it's a derivative of CDF for minus infinity to less than x less than infinity. This means if you know the CDF capital Fx of x, you can find the PDF by differentiating it. Thank you everyone.